Welcome back, everyone. Last time we learned about polynomials, how to multiply polynomials, how to add and subtract them. And today we're going to learn how to factor polynomials. So, right off the bat, how do we factor a polynomial? Well, first we want to find the greatest common factor between terms. So say we have 14x squared plus 21x. We want to ask ourselves, what goes into 14x squared and also 21x squared? And we want to make sure this factor is the largest possible. So, what goes into both 14 and 21? That would be 7. 7 would be the largest, the greatest common factor between those two numbers. Then we also have the x's, so we can take an x out of this one, but we can't take anything more. So the greatest common factor between these two would be 7x. To take the 7x out of both these factors, it's kind of like doing the distributive property, but in reverse. To take the 7x, what times 7x equals 14x squared? That would be 2x. And then what times 7x equals 21x? That would be positive 3. That is how we factor a polynomial. Okay, let's move on to a different example. How do we factor something that has this kind of format? We have an x squared, we have this b as a constant times x, and then plus a constant. What we want to do here is think, what two numbers will add up to b and multiply it together to equal c? So let's look at an example of this. We have x squared minus x minus 6. So what we're thinking here is, what are the factors that add up to -1 and multiply it together to get -6? What you can do here is you can list them out. So you have -2 and -3 are factors of -6. Multiply those together, get -6. Or it could be +2, -3. And so now you want to ask yourself, which pair of these numbers adds together to equal -1? And that would be this pair. So moving on from there, we can do x plus 2 times x minus 3. And that would allow us to factor this expression. Now, if you want to go ahead and check and make sure you got the right answer, you can go ahead and use FOIL and multiply this out. So we would have x squared minus 3x plus 2x minus 6, and simplify that down. X squared minus x minus 6, and that gives us the same thing we started with. So this is in fact the right answer. So let's look at another factoring method called factoring by grouping. Say you have 3x squared plus x minus 2. And so what you want to do here is you want to write out what the coefficients are and the constant at the end. So the leading coefficient will be a. A is 3, b equals 1, and c equals -2. 2. And so you want to think, what factors of a times c add up to b? A times c equals -6. And let's go ahead and list out our factors here. So we have 1 times -6. We have -1 times 6. You can have 3 times -2. Or you can have -3 times 2. So now ask yourself, which of these adds up to b? So if we look here, this adds up to -5. This would be +5. So those are crossed off. And this actually adds up to 1. So we want to use the 3 and the -2. To do this, we want to go ahead and rewrite this 3x squared. And this is where you incorporate your 3, so plus 3x, and incorporate your 2, minus 2x, and subtract constant. And from here, we can notice that these terms on the end look a little similar, and these terms on the front look a little similar. So the first two terms, what you want to do is factor out the greatest common factor. So the greatest common factor between these two would be 3x, and you multiply those by x to get 3x squared, and +1 to get the 3x. And then we do the exact same thing for the last two terms. We can do here, we can factor out a -2, multiply that by x to get -2x, and multiply that by +1, and it gives you -2. Now you'll notice that both of these terms have an x plus 1. And what we can do here is we can say, okay, 3x minus 2 times x plus 1 is our factored expression. So that is how you do factoring by grouping. Next thing I want to show you is factoring a perfect square trinomial. What this looks like is a squared plus 2ab plus b squared equals a plus b squared. And then for our negative square, we have a squared minus 2ab plus b squared equals a minus b squared. Anytime you see an expression in parentheses squared that takes this form, you will know that it comes out to this right here. And similarly, if you have an expression that looks like this, you know it factors down to something like this. So what does this look like in practice? Say you have 4x squared plus 12x plus 9. And what you'll notice here is this leading term is a square. It's a perfect square. And so is the last term here, the constant. So we have here is a is equal to 2x. You multiply 2x by 2x, and you get 4x squared. And the b is equal to 3. What can you do with this? Well, first, we want to check and make sure that 2ab in fact holds true for this term right here. 2 times a times b. 2 times 3 is 6, times 2 is 12. That does in fact give us our 12x. So we know that we can go ahead and use this form. Our a is 2x, and our b is 3, and that's squared, and that is how you factor a perfect square trinomial. Okay, our next factoring method is a difference of squares. So say you have something like a squared minus b squared. That is going to be equal to a plus b times a minus b. So an example of this is 9x squared minus 4. Our a is going to be 3x, because 3x times itself equals 9x squared. And then our b is going to be 2. We can use our handy dandy formula up here. We have 3x plus 2 times 3x minus 2. Okay, this next method is a bit more complicated, but it's the same premise. We have a formula here. This is factoring the sum and difference of cubes. A cubed plus b cubed. We'll follow this formula. Plus b times, a squared minus ab plus b squared. And then for the difference of cubes, we have a minus b times a squared plus ab plus b squared. Now, what I want you to notice here is when we're doing the sum of the cubes, this term in parentheses, we have a positive, just like the positive here. And then on the inside, the AB has a negative, which is the opposite. And the AB on the difference of cubes has a positive, which is the opposite of the a cubed minus b cubed and the a minus b. But the b squareds are always positive. So we have an acronym for this. It's called SOAP. What this means is these two signs on the sum of the cubes and the beginning a and b, the difference of the cubes and the beginning a and b have the same sign. So this S stands for same. And then we have the opposite sign on the AB. And then the last signs are always positive. Same, opposite, always positive. And that's just a good way to remember the sum and difference of cubes and what format it takes. Let's look at an example here. We have 8x cubed plus 1. What you want to do here is figure out what are we cubing? We're cubing 2x. We have 2 cubed times x cubed. So you can think of it like this here. And then the 1 is also cubed. Plugging this into the formula, we have our a plus our b. We have our a squared 2x squared is 4x squared minus our a times our b. We have 2x and then plus our b squared. So this right here is all factored. And to look at the negative version of this, x cubed minus 1, rewritten as 2x cubed minus 1 cubed equals a minus b, same sign, times our a squared, which is 4x squared, opposite sign, plus 2x, and then plus our b squared, which is always positive. So how do you factor an expression with a fraction for an exponent or a negative exponent? Let's start with the fractional exponents. So we have 6x to the 2/3 plus 4x to the 1/3 power. And what you want to do here is pull out the x with the lowest power. So that would be x to the 1/3. And we can also pull out a 2 from the 6 and the 4. So let's go ahead and pull it out right here. And then now you want to think about what times 2x to the 1/3 equals 6x to the 2/3. Now you want to be extra careful here. Make sure you use the product rule of exponents. So 2 times 3 equals 6. And x to the 1/3 times x to the 1/3 equals x to the 2/3. So we want to make sure we are adding the exponents. And then what times 2x to the 1/3 equals 4x to the 1/3? That would be 2. And that gives us our answer. So what if the exponent is negative? Let's say we have negative 9x times 2x plus 1 to the negative 3/2 plus 18 times 2x plus 1 again to the negative 1/2. Start by pulling out your lowest exponent again. That would be the negative 3/2. Pull out the 2x plus 1 with the negative 3/2. And this is kind of like factoring by grouping. You pull your negative 9x into here, plus the 18. And now, what power will this 2x plus 1 have? Well, if you remember from previous videos, we can use the quotient rule of exponents. Basically what we're doing here is we're taking 2x plus 1 to the negative 3/2 out of 2x plus 1 to the negative 1/2. In essence, we are dividing by that. So we will have 2x plus 1 to the negative 1/2 over 2x plus 1 to the negative 3/2. And now we can use our quotient rule. So we are subtracting negative 3/2. So we can just add it. That gives us just 2x plus 1. So negative 1/2 plus 3/2 equals 2/2. So that would simplify to 1. And so we don't have to worry about putting an exponent on this. Let's get a little more space. So now what we can do is we can bring this down here. What we want to do is use the distributive property for this 18 times 2x plus 1. So we'll get plus 36x plus 18. And we can simplify this further by pulling out a negative 9. So I'm going to go ahead and put that at the front of the whole expression. So pulling out the negative 9, we get x minus 4x minus 2. And let's simplify again. X minus 4x equals negative 3x and minus 2. And that gives us our answer. If you're still with me at this point, thank you for making it this far. I hope you got something useful out of it, and I'll catch you in the next one.